Let me now jump immediately to some economic applications of this. Instead of using X and Y and Z, we'll use different symbols, but the ideas are still the same. In this case, imagine there's a two-product firm. That produces product 1, product 2. The firm's cost function is given by this equation. Q1 squared plus Q1 Q2 plus Q2 squared. Q1 is the quantity of product 1 produced per period. Q2 is the quantity of product 2 produced per period. Okay? Imagine that this two-product firm sells its products in competitive markets. And it is a price taker in each of these markets. It can sell as many units of product 1 as it wishes at $100 per unit. So the price of product 1 is $100 per unit. The price of product 2 is $80 per unit. And it can sell as many units of product 2 as it likes at $80 per unit. Okay. Now the question is, how much of product 1 and product 2 should this firm produce? Okay. Well, we assume that the firm's goal is to do what? What does a firm want to do by assumption? Lucy? Wants to maximize profit. So our objective function is going to be a profit function. So you need to figure out what this profit function looks like. You need to figure out what the objective function looks like. Obviously, the two choice variables are going to be Q1 and Q2. Profit's going to depend on how much of these two outputs you produce. So let pi denote profit. What is our profit function going to be in this case? Revenue minus cost. Excellent. By definition, profit is revenue minus cost. Okay. What is revenue going to be, Ben? Exactly. The revenue, see, there's two parts to revenue. There's the revenue from selling product 1, which will just be 100 Q1, plus the revenue from selling product 2, which will just be 80 Q2. So this is our revenue function. Notice revenue is a function of Q1 and Q2. Okay. What is our cost function? Well, that was given to you in the problem. So all you need to do is substitute this expression in for C. So we just subtract out our cost, which is given by this equation. And let me erase this because I'm running out of room. Minus Q1 squared minus Q1 Q2 minus Q2 squared. And we have it. There it is. There's our profit function. That's the thing we want to maximize. And once you have this, then the rest is pretty routine. Paramba, what would be our next step? Paranda? What would be our next step if we want to maximize this profit function? Okay, yeah, derivative. Which derivatives are we going to be looking at? Okay. All right, Rebecca, can you help us out here? Yeah. Okay, so what we want is the partial derivative of profit with respect to Q1. Might as well start with Q1. Or we could just call this pi 1. The partial derivative of profit with respect to Q1 could just be denoted as pi sub 1. And Rebecca, what is pi sub 1? Okay, actually, but what about this one right here? Let's not forget that one. Is that what you said, Rebecca? Right. Now, yeah, minus Q2. And we want to do what with that? Set it equals 0. Okay. And then pi 2, let me write pi 2. Let me rewrite pi 1 over here, because I'm running out of room. Pi 1 is 100 minus 2Q1 minus Q2 equals 0. And then what else do we want to look at? Yeah, okay. And we'll just call that pi 2. Let pi sub 2 be the partial derivative of profit with respect to Q2. And that will just be 80 minus Q1 minus 2Q2. Set this equal to 0. Notice we have two linear equations and two unknowns. So our critical value of Q2 is 20. Now, let's check the second order conditions. Now, the second order conditions now are going to be this. Let me just rewrite this, because our notation has changed. Before, it was f sub xx. What is it going to be now? Not f sub xx, but what? Well, notice the first derivatives are this. Partial pi, partial Q1. We're defining that to be pi 1. So instead of f sub xx, what are we going to use for the second derivative of profit with respect to Q1? Well, the easiest notation would be pi sub 1, 1. So pi sub 1, 1 is the second derivative of profit with respect to Q1. It's just the derivative of pi 1 with respect to Q1. So that corresponds to what we had before, f sub xx. So we want this to be negative. We're searching for a maximum. And what is the other one? Instead of f sub yy, now we want what here? Pi sub 2, 2. The second derivative of profit with respect to Q2. Okay. Then we also want, oops, this is our second order condition. Excuse me. Our first order condition is just this, pi 1 equals pi 2 equals 0. Our second order condition is pi 1, 1 negative, pi 2, 2 negative, and pi 1, 1 times pi 2, 2 being greater than pi 1, 2 squared. Okay. All right, these would be the conditions for a maximum, just changing our notation. Now, what is pi sub 1, 1. What is pi sub 1, 1? Yeah. Pi 1, 1, negative 2. It's negative, so that's good so far. What about pi 2, 2? Yeah, negative 2. That's this coefficient right here. What about pi 1, 2? Pi 1, 2 by definition would be the partial derivative of pi 2 with respect to q1. And what would that be? Anybody? Negative 1. Okay. Partial derivative of pi 2 with respect to q1 would just be negative 1. So you can see in this case, pi 1, 1 is negative. Pi 2, 2 is negative. Pi 1, 1 times pi 2, 2 equal to 4. That is greater than 1 squared. So this condition down here is also satisfied. So again, what we have is a profit hill. And at these critical values of Q1 and Q2, Q1 equals 40, Q2 equals 20, you got a profit maximum. So the maximum profit is this. The maximum profit occurs where Q1 is 40, Q2 is 20. So if you just go back to the profit function, plug in these values of Q1 and Q2, you get the maximum profit. Let's just do that. Remember our revenue function was 100 Q1, substitute in 40, plus 80 times Q2, which was 20, minus our cost, which was a Q1 squared would be 40 squared, plus Q1, Q2, 40 times 20, plus Q2 squared. So if you calculate this number, you will get the maximum profit. Okay. And I'll let you just do that as an exercise. And that would be the top of the profit hill.